ruled, and they are improving, and we're improving the model as we continue feeding the system. So these are like self-correcting systems by time. And a complex issue is that when we have more than one hidden layers, and the data and the interrelations, the like crosstalk between the nodes and the links of this neural network of this neural network sort of model, they are even more complex than the issue is more intricate. And that's what exactly happens in the brain. So if you imagine that any of these nodes are neurons, and the links, and I mean the black lines are the neural projections and also connections. These are the exact thing that happens in the brain. While we're talking about number of nodes here, but there in the brain we're talking about billions of nodes. So that's the beauty, and that's the mystery, how the brain puts together reality and information processing for us. So that's when and why artificial intelligence and machine learning, they go hand in hand in many instances. So, and that's why you see that there is like a mega trend. Everyone is talking about AI. Everybody is going to talk about the application of AI machine learning for everything, and that's what we refer to as AOE, or artificial intelligence of everything. So there are big questions here in the middle, between the line. If we're taking a look at those mega trends, we got to be first looking at the reality. So the current status is that we have unlimited computational resources and connections. There is a pervasive computational thinking amongst the neuroscience and also the clinical scientists and technologists already. We know that whatever the future is, it will be depending on computing, and everything is recorded. Nothing is forgotten. And at different levels, like organizational, geographical boundaries, we have disappearance of all the limitations as we move. These are the reality. These are the facts that we can be that will be expected. And we're going to move towards a master algorithm, and which is like a universal learner. And as we pointed out earlier, what we would be expecting is the so-called digital quake by 2030. We would expect that 80 companies, according to the NSF PACE workshop that I got inspired by some of the data which was presented there in 2020 in Washington, DC, and that was a virtual event. Uh, we know the economic implications are huge. We know that 80% of the companies and jobs are going to be changed by 2030, and the social impact is going to be tremendous, and the world will be looking different. And we intend we have intended and unintended consequences for that, and so on and so forth. So there are so many different things that we need to have them clearly understood on the horizon. Question is AI going to give rise to neuroscience advancements, or neuroscience is going to be used for AI development? So that's a two-way street. So the paradigm, AI for NS, or for neuroscience, or neuroscience for AI, that has been a question. And this question has been beautifully tapped into in a review paper which was published in Neuron in 2017 again, by Hassabis and colleagues, and that was entitled "Neuroscience Inspired Artificial Intelligence." So, looking at the content of that paper, we'll see that for many specific uh, functional activities in the brain and neurofunctional models, including attention and also some other aspects like learning and controlled learning systems in the brain, episodic learning, and some other macroscopic organizations of the model used for the working memory and differentiable neural systems. And last but not least, for the kind of parallel link between the neurobiological models of synaptic consolidation and elastic weight consolidation algorithms, there have been huge number of researchers over recently. And as you can see here in this review, there has been some graphical outlines and illustrations on how these kind of give and takes in terms of data analysis and the expected outcome, like input, output, outcome level, how they're going to be sort of predicting and cross-linking a bunch of features to specific labels. And as you see in A, B, C, and D, we are corresponding the images to models, just kind of demystifying attention and learning systems, complementary learning systems, macroscopic organization of the models of working memory. C and D would refer to the biological models of synaptic consolidation. Okay. So this is what we pursued in one of our publications in 2013. We had big data. We had a data from one of the main leading pediatric cancer treatment and research centers in Iran, which is called MEHAC. And we had a huge bunch of evidence and data set concerning the clinical presentations and also histological, pathological, and different parameters of brain tumors and children. And to sort of classify the data, we've been using the pediatric CNS tumors in relation with the neuro-optimal feature selection and mutual information. And it turns out that when we are just putting all those data together to identify any kind of predictive models that they're going to sort of feed the system for predictive scales or predictive index of making an educated guess about the risk of development of a specific tumor or CNS malignancy. Well, it turns out that for the gender, for age of diagnosis, geographical location, parent relation, familiar cancer, prior malignancy, delivery route, as you can see, other things like history of seizure and weight loss, appetite loss. Well, we were just kind of cross correlating this kind of features to tumor location and including like a supratentorial tumor histology, infratentorial tumor histology, the glioma grade, and the tumor type. And we put all the data into different system models. One of them that I just picked up to share here with you. I'm sorry. And the thing that we're just putting this together was, yeah, we kind of demonstrated this in a spider web plot, and this spider plot shows that for the tumor uh, location and supratentorial tumor histology, we got a cross correlation and predictive, like a cross link with age. And if you see in the right top corner of this spider web diagram, for age of familial cancer and metastasis and tumor stage. I'm sorry, maybe I grab some water and I'll come back to you. Well, thank you. As you can see here, what we're discussing is the significance of any of these variables, clinical symptoms, presenting symptoms in relation with what we can expect in terms of the final diagnosis as the output and the outcome, which is prognosis, all right? So Similar to what we